Okay, so I'm going to stop sharing just so I have as much room as possible for you to see. The cube root of this, first of all, that's negative, doesn't matter because it's a cube root. Negative times negative times negative is still negative. But just looking at this, you're supposed to be able to recognize that it has factors which are cubes. And that decimal is equal to negative 27 thousandths. Both of these are third powers. Okay, this is just in section 5. It's not anything too complicated. Those are both cubes. 27 is 3 cubed. 1000 is 10 cubed, which means that this is negative 3 tenths cubed. Well, if that is the cube of negative 3 tenths, then when you take the cube root of it, you should get back out negative 3 tenths. Whenever you've got a decimal like that, you can bet that it's going to be some, power, whatever you're trying to take the root of, divided by the same power of 10, right? It would be the same thing like if it was like 0.16, right? That would be the square root of 16 out of 100, which would be the square root of 16 over the square root of 100. Do you get how that works? Okay, so that's separate. That was the answer to the top one. Let me get to the next section. I'm going to share my screen again. 5, 6. All right, so these are a bit more complicated, okay? These are, again, simplification problems, and they're going to involve the drawing out of common factors. So I'm going to do a problem like the one on the top. There's only 3. I don't want to spoil the whole thing. But notice one of the things about the top is that there are a number times the square root plus another square root. How does that work when you add square roots together? So again, I'm going to stop sharing so there's as much room on the screen as possible. How do you add square roots? What does that even mean? Well, in order to add square roots, I would need them to have something in common. So here's a way I can engineer them to have something in common. If I were to start with the square root of 3 plus the square root of 3, but then multiply them both by something else to hide that they have the square root of 3 in common. For example, I could multiply this one by 2, and I could multiply this one by, say, I guess I'll just multiply by 5. Okay, now that 2 is the square root of 4, and that 5 is the square root of 25, which means when combined with the other square root, I could have the problem the square root of 12 plus the square root of 75. Now that just looks like an impossible problem. How am I supposed to add, is it the square root of 12 plus 75, like the square root of 87? No, it's not going to be like that. What you've got to look for is that these have a common factor, namely the square root of 3. And if you can change that into this, you've got yourself 7 times the square root of 3, right? 2 of the square root of 3 plus 5 of the square root of 3 is 7 times the square root of 3. That's how you solve a problem like that. Okay. Back to these. I sure hope I can get that last section in. 5, 7. This is asking you to put it in radical form. So here's just your general rule. Okay? I think I can probably even write this so you can see it here. If you have a to the m over n that is equal to the nth root of a to the m, that is, the denominator of your exponent is always going to be the degree of the root. The numerator of the exponent is always going to be whatever the power was under the root. Okay? So like 5 to the 2/3 equals the third root of 5 squared. Sure, I can cram one more in here in 20 seconds. Why not? Oh, okay. Well, this is our last homework assignment. Or not our last one. This is our homework assignment from like Monday or something. So I think that you might be the best on that one just because it's fresh. But if I'm not mistaken, I already have some instruction on this online that you can check out, which means I can officially end on time. Okay, so as I said, this thing that I just did has been recorded. In fact, I'm going to stop the recording right now.